I'm going to find the Laplace transform of f of t, which is equals to sine squared t. I'm going to use the table of Laplace transforms. So we are given that f of t there. The Laplace transform, we denote it by f of s. So we put our f of t, which is sine squared t, then we have the Laplace transform of sine squared t. But in our table of Laplace transforms, we don't have a function which is of this form here. So what we would have to do is we have to rewrite sine squared t by using trigonometric identities so that it suits functions which are in the table of Laplace transforms. So when we use trigonometric identities, we get that sine squared t is a half minus cosine of 2t divided by 2. And then by properties of Laplace transforms, we can separate this so that we would have a half multiplied by the Laplace transform of t to the power 0 minus a half multiplied by the Laplace transform of cosine of 2t. Now this t to the power 0, that's just a 1, just because when you factor out the half there, we remain with a 1. So that's the expression that we have. We can now go on and look at our table of Laplace transforms. So from the table there, if we look at this function here, t to the power 0, it is of this form here, t to the power n. And by comparison of the two highlighted parts, we see that our n is equals to 0. And then go on and substitute n equals to 0 here, so that would have our f of s is equals to 0 factorial and divided by s to the power 0 plus 1. 0 factorial gives us a 1, so our expression becomes 1 divided by s. So that's the Laplace transform of this highlighted part. So our expression will then become half multiplied by 1 divided by s. And then go on and look at the next part, which is this one here. We see that it is of the form of cosine of at. And by comparison of the two highlighted parts, we see that a is equals to 2. So a equals to 2, we substitute it here, so that we would have our f of s is equals to s divided by s squared plus 2 squared. 2 squared, that's a 4. So our expression becomes s divided by s squared plus 4. So that's the Laplace transform of this highlighted part. So our expression will then become minus a half multiplied by s divided by s squared plus 4. So and that's the Laplace transform that we have. But the 1 over 2 is common here. We can factor it out so that we have 1 over 2 multiplied by 1 divided by s minus s divided by s squared plus 4. So that's our solution there.